our next miscellaneous equation is the type when we have rational exponents, okay? Not just x squared or x cubed or x to the fourth, but a fraction, okay? So first of all, let's remember how to evaluate these, besides on our calculator. I get it. We can evaluate it on our calculator. But 4 to the 1/2, the denominator means the root. Okay, so this is square root of 4 to the numerator is the exponent. This is the square root of 4 to the 1, which we would, of course, just say the square root of 4. 4 to the 1/2 is 2. Okay, so look at the rest of these. And using that idea that the denominator is the root and the numerator is the exponent after you do this root or before, let's see what you get for 9 to the 3/2. 8 to the 2/3, etc. Okay, pause me for a minute and try this on your own and then come back. Okay? So 9 to the 3/2, denominator's 2, so square root of 9 to the 3rd. You have two choices, guys. You can take 9 to the 3rd, which is 729, and then take the square root of that, which is 27. Or you can take the square root of 9 first, which is 3, and then cube that, which is 27. Either way, you get the same answer, okay? In this case, 3 is the denominator, so it's the cubed root of 8 squared. And again, I could take 8 squared and get 64, take the cubed root of 64 and get 4, or I could take the cubed root of 8 first and get 2, and then square 2 and get 4. Either way is fine, obviously. 8 to the 3/2, we get the square root of 8 cubed. I can't take the square root of 8, can I? Not evenly, right? It's 2 root 2. So in this case, I might just go ahead and cube it. So 8 cubed in my calculator is 512. And then to simplify that, if I cut that in half, I get 256. Okay, so 512 is 2 times 256, and the square root of 256 is 16. You have to fool with that on your calculator, and find those things. But you get 16 squared to 2 would be the simplified form of that, okay? 16 to the negative 3/4. Anytime you have a number raised to a negative exponent, that's 1 over that same number raised to the positive exponent. So this is 1 over the 4th root of 16 cubed. I can take the 4th root of 16, it's 2, right? 2 times 2 times 2 times 2 is 16. So this gives me 1 over 2 cubed. I get 1/8. I know that you can get a lot of these on your calculator. This one you can't, okay? But the rest of them you could have gotten on your calculator. 24 to the 4/3. That's the cubed root of 24 to the 4th. Again, can't really take the cubed root of 24. So maybe I'll simplify that first, though. Do it the opposite way as we did this one up here. What's 24? Perfect cube would be 8, right? 24 is 8 times 3. Cubed root of 8 is 2. So this is 2 cubed root of 3, and I'm going to be raising that to the 4th. Okay, so you could do it that way if you prefer. 2 to the 4th is 16, so this gives me 16 cubed roots of 3 to the 4th is 81, right? 3 times 3 times 3 times 3. Now, notice I did say 3 times 3 times 3 in there. So 81 is 27 times 3. And the cubed root of 27 is 3. 3 times 16 is 48. So we get 48 cubed roots of 3. I don't know if you think that's easier, or taking the cubed root of 24 to the fourth, which is 3. It's like 331,000 something. Okay. 24 to the fourth, 331,776. Yeah, I'm not a fan of that. 331,776. Yeah, I think I would go this way to simplify that. Okay, so just a refresher on rational exponents. So now we're going to be asked to solve equations that have rational exponents. And what I want you to remember is, if you have a power raised to a power, you multiply those exponents, right? So if I have x cubed and I want to get rid of the cube, I'm going to raise it to the reciprocal, 1/3, because then I'm going to take 3 times 1/3, which is 1. That's what we want, x to the 1. So that's what we're going to do here. I'm going to raise each side to the 2/3 power, because 3/2 times 2/3 is 1. So I have x to the 1 equals 27 to the 2/3. So that's the cubed root of 27 squared. So x equals 3 squared, right? Cubed root of 27 is 3. So we get 9. Okay, so the key is raising it to the reciprocal exponent. And that's what this little strategy is telling me here. Raise each side of the equation to the reciprocal power. Okay, if it's x to the m over n, we're going to raise it to the n over m power. And it goes through and reminds you that this is the nth power of the mth root. Okay, remember that there are 2 even roots of any positive real number. And there's exactly 1 real odd root of any real number. So in other words, if it's a square root, you have to put the plus or minus. If it's a 4th root, you have to put the plus or minus. Any even root, you have to put the plus or minus, because there's 2 real even roots. If it's an odd root, you don't have to worry about it. There's just 1. If m is even and k is bigger than 0, then we have the plus or minus. If m is even and k is less than 0, well, then I'm taking the square root of a negative, or a 4th root of a negative, and that's going to be no real solution. Okay, if you want to put the I in there, you can, but right now we're wanting real solutions for this. Okay, and if m is odd, then there's only 1 real solution. So let's try that with these problems. Sorry for I just noticed they're really fuzzy. This says x to the negative 3/2 equals 1/8. I am just going to totally go by what they just told me. They said raise this to the reciprocal power. Well, the reciprocal of negative 3/2 is negative 2/3. So I am going to raise this side to the negative 2/3 power. And I'm going to raise this side to the negative 2/3 power. Negative 3/2 times negative 2/3 is positive 1. 1/8 to the negative 2/3 is the same as 8 to the positive 2/3. So x is the cubed root of 8 squared, which is 4. Here I'm going to raise both sides to the 3/4 power, so that I have x to the first, 625 to the 3/4 power. That means it's the 4th root of 625. See what I'm doing here? Even root. Here I was taking an odd root, so I only had one answer. Here I'm taking an even root, so I better be careful. It's actually x equals plus or minus whatever the fourth root of 625 is. I believe it's 5, right? 5 times 5 is 25, times 5 is 125, times another 5 is 625. This is what they were talking about. You have to have the plus or minus there, guys, because I'm taking an even root. Okay? If I take negative 5 to the 4/3, I'll get 625. If I take positive 5 to the 4/3, I'll get 625. Okay? All right. Okay, guys, I just heard myself say something wrong. We took the fourth root of 625. See, this is where if I was in class, you guys would have stopped me because you probably were stopping me while I was, but you couldn't because I'm on video. I didn't do anything with this 3, just ignored it. It's the fourth root of 625 cubed. So I have plus or minus 5 cubed. Okay, I can take the fourth root of 625, that's plus or minus 5, but I forgot the cube along the way somehow. And then when I was saying the answer, I was like, wait, that doesn't make sense. X equals plus or minus 125. That's better. 125 to the 4/3 is 625. And negative 125 to the 4/3 is 625. 2 answers. Sorry about that. I just kind of dropped the numerator. Okay, so here we'll solve this problem. We'll raise each side. Let's see. Give you a chance to write it down. Y minus 2 to the negative 5/2 equals 32. Let's raise it to the negative 2/5. Right? We want to raise each side to the reciprocal. So if this is negative, I raise it to a negative. Negative 5/2 times negative 2/5 is 1. So if y minus 2 to the 1 equals 32 to the negative 2/5 is 1 over 32 to the positive 2/5. So if y minus 2 equals 1 over the 5th root of 32 squared, y minus 2 equals 1, 5th root of 32 is 2, so 1 over 2 squared. Y minus 2 equals a 4th, so it looks like y equals 2 1/4. Okay. Going against the clock here. All right, this is a quadratic like with rational exponents. Okay. 1/3 squared is 2/3, right? So I'm going to solve this like it's a quadratic. I'm going to have x to the 1/3, x to the 1/3. If I multiply those, I add exponents and get x to the 2/3. Something that multiplies to 8 but adds to negative 2 would be a negative 4 and a positive 2. So I have x to the 1/3 equal or plus 2 equals 0, or x to the 1/3 minus 4 equals 0. X to the 1/3 equals negative 2. If I cube both sides, I get x equals negative 8. X to the 1/3 equals 4. If I cube both sides, I get x equals 64. So those are my 2 answers, negative 8 and 64. Same thing here. I just need to bring this over to the other side, so I have it equal to 0. 1/4 squared is 1/2. So I would solve this one as well, as it was a quadratic. Okay, 1/4 times 1, x to the 1/4 times x to the 1/4 is x to the 1/2. I think I'll do a -1 minus 6. That's not going to work, is it? So it was 3 and 2. X to the 1/4 minus 3 equals 0. So x to the 1/4 equals 3. Raise both sides of the 4th, etc.